This is Port of Dover. We are the UK's busiest international ferry port for tourist and freight vehicles. Every year we carry about 1.6 million tourist vehicles, 11 million passengers and 2.2 million freight vehicles. And that equates to £144 billion worth of trade, which is approximately 33% of the UK's trade with the EU. We are a very important port in the UK, and without us, the UK would come to a grinding halt. Port of Dover faces many challenges in regard to traffic management. Because we're quite a small site and we're constrained by the cliffs behind us and the sea in front of us, we can't expand our footprint. However, we do have really good traffic management plans in place that we utilise during busy periods. And we know when those busy periods are because we plan and we forecast for them.
Together with the Port of Dover, we've deployed what we call an AI-enabled digital twin, which helps to predict and forecast traffic arrivals to the port entrance, ultimately helping operators to make informed traffic management decisions.
The original goal is to monitor and ascertain the traffic figures with accurate predictions of what's coming to the port, especially if we can marry them against what the ferry operators are saying that we've got booked. And once we can ascertain that those two figures marry up and are accurate, we can then dictate how many resources we need at the port to make sure that the customers, once they arrive, have a pleasant experience for their onward journey.
So we've been working with NTP for about 1.5 years to 2 years. Initially, we kicked off working with them on our Connected Places Catapult project, so that's the innovation project. We were looking to bring AI into the port for the very first time. Off the back of that, we then worked with them for another 6 months roughly, where we really refined the offering, really thought about how we were going to use it in a production context. And then since the beginning of this year, we've been using it in full production mode. You can see it on the screens behind us on the workstations. We have everybody in terminal control using the application now.
At the heart of the system is the concept of digital twin, which orchestrates the outputs of multiple AI micromodels and real-time data. These AI micromodels are very small, very focused artificial intelligence models that are deployed across the entire strategic road network of the port, going all the way up to the Dartford crossing. And these models predict traffic flows at specific parts of the road with absolute precision. The outputs from many AI micromodels are then integrated into the digital twin, together with real-time data around things like car accidents and roadworks, which ultimately inform traffic flows. This network of intelligence then informs our prediction for traffic arrivals to the port.
The intelligence is trusted. We've had it a while now. It's a learning tool. There are various sensors along the approach roads, as well as we're piggybacking CCTV and an element of AI, which is then calculating how much of the traffic on the A2 and M2 approach roads and the A20, M20 approach roads is coming towards us. Because we've had it installed for quite some time now, we then every week send the figures that we have had historically back to NTP, and then they're able to generate the graphs which dictate that it was actually accurate overall.
So I think fundamentally it's been about really building a very close-knit relationship with NTP, and that's been for them to understand exactly the context, different factors at play in the operations of the port and beyond, and for us to really give them as much input as we possibly can.
This is the dashboard page of the NTP system. It didn't start looking like this, but over the period of time we've tweaked it, we've given our feedback, and we were able to have the layout just that's most beneficial to us. You can see across the top line that we've got freight, and it's predicting how much we'll have in the next hour, 2 hours, 3 hours. And then we've got some color coding which suggest whether or not we're going to see significant increases, decreases, or plateauing of the figures. Likewise, that's duplicated with cars and coaches. And on the bottom line, we're able to have a look at what the ferry operator's input is happening. Every vessel that leaves here leaves with a specific amount of cargo and passengers on board. They will upload that data. So instead of me having to flip between other screens, I'm able to, at a glance, see how much of the traffic has left the port, and it also gives me a running total on percentages.
Because we're such a small port, we have really robust traffic management plans in place, and these are put into play 3-4 times a week. We have the ability to hold freight on the A20. That's managed by our own port police. These plans have been developed in conjunction with Highways England and Kent County Council, and they work really well during our busy periods. We also work closely with the ferry operators and with our French police colleagues to ensure that they have the ability to process the traffic to meet demand as it comes into the port.
And finally, on the dashboard system, we've got a couple of extra toggles that we'll use when we are actively queuing traffic outside of town to keep disruption and congestion free for our local neighbours. We'll tell the Entropy system that the traffic access plan is active, and then we can release the vehicles off of the A20 at our rate that's in line with what we have room for here.
So we really want to continue to improve the capability that we have. You maybe can see behind me that the port is constantly changing. So there's a lot of change that we would need to adapt for and build into the model. Our biggest kind of aspiration is that we start to break out the data so that we use it beyond the operational team. We think there's all sorts of stakeholders in the port that will benefit from having access to that prediction data, so they can kind of factor into their own planning, forecast planning, and so on. So that, I think, is the next big bridge that we want to cross, really kind of break out the value of the data that we collect.